Hello guys, today we are gonna try to do object detection. Firstly, let's explain object detection. You are training your computer actually, and you are trying to know the objects by showing the computer. Uh, let's break up the parts because it's a little big project. First, we need to download all the images that we need. We can say that dataset to the image. To download our dataset, we have to use some extra tool actually, because when you don't use extra tool, you are gonna really be in painful. You have to download a lot of images, like thousands of them. In this way, you are gonna be able to make a good impact on computer, and computer is gonna respond to you like you want. So we are gonna use Google Chrome API. You can click that link in the slides, and you're gonna come here. After that, you can download this API, and after you download it, you're gonna see that icon in the right corner, and you just have to type something that you wanna be detect. After that, you are gonna go to images, and you have to scroll down like the end of the images. Let's scroll down a little bit. Maybe you can stop when you don't see the actual images that you want to see, that you want to detect actually. That's enough. After that, you are gonna push the zip button. You have to wait a little bit, like 1 minute, and after that you are gonna have a zip file. I'm gonna show you in a minute. Finally, we downloaded our images, our dataset. We are gonna train this dataset, and we are gonna be able to detect them. But in this video, I am not gonna detect guns. I have 10 classes, 10 classification, and I'm gonna try to use them. Now let's go to the second part. We are gonna learn how to train our dataset. Firstly, we should know which environments we are gonna use. Anaconda and PyCharm, the environment that we are gonna write code in. Keras with TensorFlow background is the model, we can say model creating background. Secondly, we should learn which libraries we are gonna use and what these libraries actually do. Firstly, Keras, like I mentioned, Keras is a library to create and save our model. This is our main library, and we are gonna use Keras with TensorFlow background. sklearn is a machine learning library too. This library actually allows to use some algorithms to label our data sets, splitting train and test data. This is a very common thing in the training our model, machine learning model, and so on. OpenCV is a library to process the image, to save the image, to process the image, to get the image. If you wanna do something with the image, you should have to use OpenCV actually. Emutils library is about images like OpenCV. We are going to use for sorting our image data. We are gonna see all of them in the code part. OS is like a file API. We can say all the file process. We are gonna use OS. And Matplotlib is a library to sketch graphs in general. We are gonna talk about in the code too. Qt library is to make a user interface. And lastly, pickle. We are gonna use the pickle to write objects in a file. This is our code part. You can see my objects. I downloaded all of them. Apple book, cookie, keyboard, and so on. And the first part is the training model. We are going to use Keras optimizers, Immutos library, Matplotlib, NumPy, argument parse. Argument parse is like a parameters in general. Random library, pickle, OpenCV, CV2, import and OS, the file library. Let's go on. We have data. This represent the objects, labels. This represent object's name. I am checking this is the data set that I am gonna train, and actually this is object class, and I am checking if it exists or not. If it does not exist, I am gonna exit the code. After that, we have to sort our images like this: Apple book, cookie, keyboard, and we are gonna shuffle them. Shuffle means firstly you are seeding your random library with some value. After that, you are randomly select them. We can say you are randomly select them. After that, you have to read each image and you have to resize it. The idea of resizing it, while you are training your model, if you don't resize images, there are a lot of different size of images, and in this case you are not going to be able to make the computer learn, because there are a lot of datas, and these are not the same concept datas. And we are adding our resized image to the data list. After that, we are getting the label from the files. Like in objects, I have Apple. So when I go to the OS path separator and -2, it's gonna take the Apple or book label, and it's gonna add to label list. And when I add the images, I should have to divide by 255. The reason because of that, your image values has 0 between 255, and I want to make it 0 between 1. Because of that, I am dividing by 255, and I am making array from labels too. Train X, test X, train Y, test Y. Firstly, let's explain the train and test concepts. In general, when you are trying to make a model, you have train part and test part. The train part is 75% approximately, and test part 25%. After you train your data, you are testing it too. And we are using train test split data. From which library? From sklearn model selection. sklearn library actually. We are using label binarizer functions. This label binarizer function makes it 001 or 010, these kind of labels with the names of the objects. For example, when I say apple 001, book represent 010. After the label binarizer, we are using fit transform and transform functions from sklearn. As this function, this is the mean and this is the standard deviation. You are subtract from the mean and divide by standard deviation. The difference between fit transform and fit, with fit transform you are changing the value that you subtract with and divide by standard deviation, but in transform you are not changing it. And we are splitting the train and test y, test part actually. After that, we are using image data generator from Keras processing. The image generator concept is that you have a lot of images but just one side. For example, you have a cat but you are just looking at from the front. When you want to change the images and if you want to train your data correctly, you want to use that function. Let's check it. This is the image generator actually. This is our cat, and after we generate our image, this cat's a lot of cat versions, image versions, and you are gonna be able to train your model much better. Let's move on. Yes, and the epoch concept is very important, I think. Epoch means you are training your data, or you can say that while you are doing some homework or you are preparing for an exam, you repeat, and you are trying to be familiar with. Epoch is like that too. When you are training your model, your model has to repeat the processing after and so on. The next thing we are gonna do is we are gonna make optimizer. Optimizer means that you wanna make your model very efficient, and there are some kind of optimizers for that. You can search it, and we are gonna compile our model. Our loss is categorical cross entropy because we have 10 objects. For this kind of issue, you can use categorical cross entropy. It's very common. We are training our model. We are using fit generator function. We are giving the train x, train y, test x and test y. Steps per epoch means we did epochs actually 1000 in here, but after that we can give the number in here too. This number means the inner circle. You are training, you are repeating the inner circle, but this number means the outer circle. You can think like that. And I am going to predict, use predict function. This predict function from Keras again. Actually this part is the test part, and we are gonna able to see the results that we made from our model. Finally we are gonna plot our results. and we are gonna see the efficiency. After that, we are gonna save model, and we are gonna write the labels and our model in a file. In the training part, I didn't mention the set model function because the set model function wasn't the functions from the libraries. I did write it. Now I am gonna talk about that function. These are the images size, as you guess, and this is the depth. When you have grayscale image, the depth is gonna be 1. When you have the color image, the depth is gonna be 3. And classes length, you can type any integer number in it, but this is the best decision, I think. You can just say these are the label classes length. Let's dive in build model, set model. We have a class set model, and we have a function build model. In this build function, we are now creating our model. Sequential model is from Keras, and it's the simplest model. And we are checking our image data format. Let's explain what image data format is. There is 2 types of image data formats. The first one is you are putting the depth parameter in the first. The second one is you are putting depth parameter in the last. And Keras supports 2 of them. So I should have to check it. If I have channel first, I'm gonna take depth from the first parameters. Else, I'm gonna take depth from the last parameters. And now we are gonna create our convolutional activation and max pooling functions. Now let's explain them. I want to explain first convolutional layers actually. Convolutional is gonna detect the difference from the images when you have thousands of image docs, for example. It's gonna take each of them and it is gonna try to find the common parts. After that, you are gonna create a model. We are creating our convolutional 2D object. After that, we are creating an activation. We are adding our model and activation. Activation is like a probability function. These are the activations most commonly used, and I am using ReLU activation. The reason because of I am using actually I did some research and I found that ReLU activation is suitable in my case. I am creating these convolutional layers. After that, I am flatten them. Flatten means you have a three layers and you are making one. I didn't mention the dropout and max pooling. The dropout I'm gonna mention in the last part. But max pooling is a very efficient thing. Actually, think like it's an image, and this image has some values, and you have a lot of image data, and you want to be efficient. You wanna be efficient in them. The thing that we are gonna do with max pool, for example, in this case, 2 max pool, we are gonna detect 2 what can I say, pixels, and we are gonna read the values in it. For example, in this case, we are gonna see the 12, 28, 12 values. The biggest one is 20, sorry. We are gonna take 20, this new image, and this part of data we are gonna take 30, and we are creating a new image. And in this case we are gonna be more efficient in the real life. I did mention about activation. Let's move on. We created our model, and lastly we have to specify the dances. You can play with dances. I did play a little bit, and it was the most efficient way in my case. So I did 64 and 128, 256, 128 and 64. These are means that each layer, you have a lot of layers. Each layer, think like a neuron in your brain. Each layer, the computer has this number of neurons. When you specify the neurons, you have to add activation. It's a value, I did mention that too. And we are gonna add dropout. The dropout means, I should have to use the image actually. Let's explain dropout. As you see, there are a lot of connections between neurons, but these connections are not the same. Each connection has a dense, and think like one neuron's bounds is more strict, but the other neuron's bounds is more soft and light, and we are detecting the light ones and we are deleting one. The final touch is we are gonna add our model dense, and we are gonna add the activation, and these activations are the most common activations actually. I didn't choose because I did try all of these. I did some research, and it was the most common activation functions in my case. So we are gonna run our model now. Because I did use argument parser, I should parameter like that. This is my dataset path. This is my model path that I am gonna create. This is my label binarizer path I am gonna create, and the last one is the graph that I'm gonna look at the efficiency from, and it's an PNG file. After I run it, you are gonna see the using TensorFlow backend, and you are gonna see the processing. As you see, the first epoch does contain 1000 from 1, and each epoch has 20, let's say, revise, and we are seeing the loss and accuracy in here. The 1000 epoch is gonna take a lot of time in my computer, so I want to show the model I did created before the video, loss and accuracy graph. This is my object label pick. Because it's an object, you're not gonna be able to read correctly. And this is my model. Okay, like that. Firstly, I wanna show you my UI, and after that I am gonna explain what I did here. I am selecting an image. I did create an image data in here For example, cookie sample. I am opening it and I am saying guess the image. All right. The model has predicted very efficiently, I think. Cancel. Let's try another image. Sorry. Yes, the image. Okay. Yes. What I did here is actually, firstly, I should have to explain the predict part. In predict part, I created a predict class and created the function predict image. It takes image path. This is my model path that I created first in the video, and my label path. I am checking if these paths exist or not. After that, I am reading the image and I am resizing it 64 to 64, and I am dividing by 255. I did explain why I did these alls in the first section, and I am reshaping my image to predict the image from the model. And this is the keras load model function. I am loading from the disk and creating a model from the disk. After that, I am creating a label too, and the function predict is a keras function too. I am not doing anything in that function. It's an keras function. Just I am giving the image after I reshape the image, and I am taking the most how can I say, the most bitti bu. And I am taking the biggest with the biggest probability index, and I am writing it to see which object is my guess, and I am printing that text because I am using this run model class in my user interface. I am returning predictions and labels. In my user interface, I am using the PyQt5. The PyQt5 has a lot of functions, of course, because of the user interface library. I am not going to explain all of this, but in my guess button, I am trying to do predict image from my path. I am reading that path and reading that image, and I am trying to predict that. After that, I am labeling that result. That's it actually. Let's run it again. This button popping the file API, so I am gonna be able to choose an image file. I am opening it. You can see the path here, and I'm gonna try to guess the image. Okay, the model is loading and is predicting, so it's gonna take a little time processing. And I am getting my result with my label and with my prediction. Thank you for listening, guys. I hope this helps a little bit to train your model or to make a object detection project. See you later.